Woohoo, we're live and I'm focusing. We're live with focusing. If we can get it to focus, let me bring in a squirrel to help us focus. There we go. Okay, this is Math 60, 1.2, the real numbers. At which point I would be asking, wait, if there are real numbers, are there imaginary numbers? And the answer is yes, there are. We will be learning about those, but not right now. Right now, we're talking about real numbers. And what the way we're going to do this is to talk about Venn diagrams. Venn diagrams are diagrams that look like this, where we've got circles or ovals inside of others to show how different sets, in this case, these are sets of animals, interact. But we could also talk about numbers, which we will be doing. So we're going to begin this with animals. And I realize it's a little bit hard to see, so let me read to you what these say. In here, this is a little pink circle. It says chinchillas, then mammals, animals, life on Earth, life in the universe. And so one question which normally I would ask the class, what would be a good title for this Venn diagram? And there are a lot of different answers. You could just say this is animals, or you could say life, or you could say categories of life or categories of animals. So all of these answers would be fine. Let's see, I've got to pick one. And again, I'm going to choose categories of life in the universe, which is what strikes me as interesting right now. But you could choose another title. So as we look through this, the cool thing about Venn diagrams is they show us that, for example, the set of mammals lies completely inside of the set of animals. Set of animals lies completely inside of the set of life on Earth. And so the question is, where would lizards fit in? And if we think about lizards, a lizard are reptiles. So do they fit in inside the chinchilla circle? No. A chinchilla, in case you're not sure, a chinchilla is like a little rodent. They're kind of a cross between a rat and a rabbit and maybe a squirrel. They're actually quite adorable and very soft. So they are mammals. Lizards are not mammals, so they do not fit in this circle. Are they animals? Yes. So I'm going to write lizards, animals. So I can put lizards like right here. And I'm going to put that inside the yellow that says this animal, this group of animals, is part of this larger set of animals. Next question, how about roses? Where would roses go? Well, roses are plants, which is a type of life, but it's not an animal. They do grow on Earth, so I can put them in here. So hopefully that's kind of making sense. In each of these sets, I can put something, I can list the different categories that fit into each section. So that's a very basic Venn diagram. Now we're going to go on to the sets of numbers. And one thing people often ask is, oh my goodness, there are so many sets of numbers. This is a lot. Do we really need to remember all this? And the answer is, I would encourage you to, for as long as you're going to be in math. Those of you who are going to study math, if you're going to go on to calculus, you should know these for sure. If you're almost done with math, then I would say learn them well enough to use them in this class. But then you're right. I don't know that out in the real world, these come up very often. But again, anytime you're in a math classroom, this is going to really help. So let's talk about the set of numbers. First set is called the natural numbers. It's written as a bold N, or you can also write the symbol like that. And it is also known as the counting numbers. These are the first numbers that people started using. They counted things that were there. One thing, two things, three things, etc. The next set we talk about is the set of whole numbers. This is massively important. If you look here between this set and this set, you'll see a difference. The difference is right here. The introduction of zero is such an important part of any culture. And if you look at cultures all over the world, as soon as their mathematicians start to talk about zero, the culture just explodes and thrives. The one counterexample to this that I know of is the Roman, Roman, oh, I'm a blank. The Roman culture, it's a word that, Roman Empire. Oh my goodness, too sleepy. So the Roman Empire didn't use zero. The Roman counting system did not use zero in it. So that's an interesting counterexample. But you can see zero popping up all over the world independently, and it's just amazing to watch what happens. This is so important that this set gets its own name, even though the only difference is that zero. We write it, and again, this is a stylized N. This is a stylized W. This is another way to write this. Next up is the integers, and it's a Z. And you also write that like that. You can also write it like that. And if we look at this, we see there's the 0, 1, 2, 3. So these are very similar, but they also have, and I'm going to draw a line underneath, the negative numbers. So these are brand new. We've got the negative numbers. And they're called integers. Notice that there are two ways to write this. You can either write it dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. So we write kind of the middle. Or we can take the whole set and fold it over on itself. And then we get 0 plus or minus 1 plus or minus 2 plus or minus 3, dot, dot, dot. So we start here, natural numbers, we add 0, then we add negative numbers. The next larger set is the set of rational numbers. Now the word rational comes from the word ratio. These are the fractions. So let me use a new color. These are the fractions. Okay, and it says the set of numbers that can be written as a fraction, or the set of all numbers that are either terminating or repeating. Let's talk about what those mean. So terminating means that decimals that eventually end in all zeros. So in other words, 4 is 4.0 and it stops. You can stop writing it. You don't have to keep going. -5/20 is -0.25. And then again, it stopped. you can write it like this, but these zeros are unnecessary. Okay, what about this one? 0.123456789, and then look at those. Whole string of zeros. So decimals that eventually end in all zeros, this ends in all zeros. So these three are terminating. They stop or they end. Okay, so that's what a terminating decimal is. I wish I could do accents, because I would do Arnold being the terminating decimal, but I can't. So I take it all back. I wish I had not even said that. Okay, repeating decimals. Well, these are a little bit easier to see. You can see that this one, which is 1/9, is 0.11111111 forever, which we write as 0.1 with the bar over it. And if we write the bar, that tells us that these ones keep going. Now notice this one, 7/11 is 0.636363. So we've got 63636363, etc. So we can assume that this is 63 repeating. Does that make sense? It's pronounced .63 repeating. That's how you pronounce it. 0.63 repeating. Woohoo! So these are all rational numbers, and this one also has a fancy way of writing it. That's the symbol here. And the question is, how do we write the set of rational numbers in set notation? Much like we wrote, here's the natural numbers, here's the whole numbers, here are the integers. So how do we write that for the rational numbers? And the thing is that if I try to write, like I could try with 1/2 and 2/3 and 4/9 and -5/11. This is disorganized. And it leaves some numbers out. So what we're going to do instead, we're going to use set builder notation. It's this guy right here. Again, I truly believe if you have a highlighter, nothing bad can happen. So I'm going to use set builder notation down here. And the way that I'm going to write set builder notation is instead of listing them individually like this is a mess. It's hard to write them in an order. It's possible, and in fact, that's a big part of math, was somebody came up with a way to write it out, but it's very complicated. So instead of doing that, I'm going to write a recipe. We write set builder notation is like a recipe. So I'm going to say that fractions, things that can be written as fractions, basically look like something on top and something on the bottom. So I'm picking A and B just to be my stand-ins. Okay. So this is going to be this. The brace right there means the set of all. A over B. Now, this long line is like a curtain. This is the pretty stuff. Back here is going to be the legal rules. So I'm going to write such that. Now, this is old-fashioned way of saying so that. So let's see, such that. And then let's see, I want to say, and here I'm going to say it, and don't panic. Do not panic. Oh my goodness, I'm suddenly it's Greek, except that's not Greek. This is a special language that we use to talk about sets. And so I'm introducing it to you right here. And this whole piece right here means it says such that A and B are integers. So make A and B. So in other words, A and B, either one could be positive or negative. And it could be any of those numbers, 1, 2, 3, 4, 5, 6, 7, or -1, -2, -3, -11, whatever we want. Put a number on top, put a number on the bottom. This little guy right there, that little E looking guy, means is an element of. That's what that means. Okay, and then I've got one more thing to add. Because B is in the denominator, B can't equal 0. The set of all, A over B, such that A and B are integers and B is not equal to 0. Woohoo. So what are we going to do in the next video? Well, because this one's gotten pretty long and the next thing I'm going to talk about is going to be pretty long. So the next time, squirrels and pizzas is our next video. And then after that, we'll continue on with some more sets of numbers. Woohoo! You guys are awesome. You did it. We made it. That was some pretty hard stuff right there. Again, if you have any questions, ask me on Pronto. Ask me, send me email. Ask the tutors. Ask each other. Go out, scream to the universe, please explain math. Woohoo. See you guys in the next video.